In this discussion, our panelists will present their efforts to accelerate innovation through partnerships with Department of Energy programs. This session will showcase the new capabilities and technological breakthroughs enabled by shared innovation infrastructure and new innovation models, while promoting engagement opportunities and efforts to scale programs. Please welcome the Honorable David Danielson, Assistant Secretary for Energy Efficiency and Renewable Energy at the Department of Energy. Peg Folta, Deputy Program Manager for Energy and HPC4 Manufacturing Program Director at Lawrence Livermore National Laboratory. Will Joost, Technology Manager for the Vehicle Technologies Office at the U.S. Department of Energy. Sebastien Lounis, Co-founder and Lead for Communications and Marketing for Cyclotron Road. And William Peter, Director of the Manufacturing Demonstration Facility for Additive Manufacturing at Oak Ridge National Laboratory.
All right, I know we're doing well when we have to kind of box in all you rowdy people from your networking. I know that we're achieving what we want to achieve when we're at that point. So, been a great day, but I hope that we've saved the best for last for you with this panel. This panel is really going to be all about what I call quick pitch deep dives on some of the really exciting programs you've heard about today, on what are these programs really doing, who are the people leading them, and how do you plug in? And so I think we'll basically give each of our panelists the opportunity to present some remarks up front, and then I think if we have time, I'd love to just go straight out to the audience with some questions and answers. So I think with that, I'd like to invite our first panelist up, Ms. Peg Folta, who is our Deputy Program Manager for Energy at Lawrence Livermore National Laboratory and is the Program Director in charge of our HPC for Manufacturing Demonstration Facility. Let's welcome her to the podium.
Thank you very much. I have the coveted first speaker after lunch spot, so I wore orange so I can wake you all up and keep your attention. I'm here to pitch, HPC for Manufacturing program. Program is just about a year old, and so I'm going to tell you a little bit about it. In a nutshell, the goal of the program is to assist the U.S. manufacturing in the adoption or advancement of high-performance computing. So it's been talked about already today, but the DOE National Labs are world leaders in high-performance computing. So why not leverage that expertise and help our nation in U.S. manufacturing? Why not take the expertise and do a PI to PI partnership and really identify the U.S. manufacturing challenges, particularly in energy efficiency and clean energy technologies, partner these people together, and we will solve the problem. Seems very simple. But indeed, there still is a great divide. There's a divide between national labs working with the manufacturing sector. And we've seen a number of showcase examples where it's worked fabulously, but it's not necessarily the norm. It's not easy. So that's the goal of the HPC for Manufacturing program, to help really bridge that divide on a person-to-person, PI-to-PI basis. So the Advanced Manufacturing Office, and Mark Johnson in particular, had understood about the endemic project program that the council led several years ago, and he was also aware of the HPC for Energy pilot program at Lawrence Livermore Laboratory. And he thought, this is a great mechanism, this is a great infrastructure. Let's learn from those programs and stand up something similar. And so thus was born the HPC for Manufacturing program. The main tenets of the program are the public-private partnerships. So the PI at a national lab works with the PI in industry to solve a problem. And the funding goes to the national lab. So we pay the national lab, PI, and the cycles to work with industry on their most challenging problems. And this is created, we said it earlier, that it's all about the personal connection, and this is creating that personal connection. We have a very streamlined public-private partner execution. We adopted the DOE short form CRADA from the MDF, And so that has worked very effectively, as you heard today, kind of the 8-week kind of time frame to execute projects, so it goes swimmingly. And the other most important thing about this program is to really build the HPC for manufacturing community. So once these projects are completed or when they're in process, it's very important to get the results and the program and what's coming of it and the impact it's having out across the entire industry so they understand what can be accomplished by high-performance computing. Now, we don't share IP, obviously, but you do share the fact that it has had an impact, that working with the national lab has had a large impact in adoption of high-performance computing. We're also working very hard to develop student programs because we also heard about the workforce as being a major issue. So this year we had summer internships working on all of the projects. By next year, we hope to actually develop a summer program where we bring in academics and maybe even have some curriculum involved. Okay, so it's been a year. Where are we? We've launched 5, we call them seedlings or pilot projects. They're in various stages of execution. One is completed. We awarded 10 projects from our first solicitation, which was originally announced at last year's AEMC Summit. We are in the process of our second solicitation. We just received another 42 concept papers from that solicitation, and I was very happy to see that it was very diverse from the first solicitation. Different companies, different challenges, different industries. And you'll see all of the current awardees are on the right. It's a very widely and very diverse set of companies. You have very small companies like the Zoom Essence, who's learning about or trying to understand how you dry. They have a technique for drying spices, so modeling that drying spices. To very large companies like United Technologies, and you heard some of their projects earlier today. You have things from Global Foundries, which is in the chips industry. And you have things like consortiums like Agenda 2020 for paper manufacturing. So it's a very diverse set of companies. Let's see. So going in the future, we are now in steady state, so we'll be issuing 2 solicitations a year. In the end of the summer and into the fall, we'll host probably our first annual Industry Day. Industry Day is where we invite members of industry to come and hear about the program, hear of all of the impacts, and more importantly, to get feedback from them on how impactful it is and how it could be more impactful, because you're always trying to get better. And continuing to build that community. One of the biggest challenges of this program is reaching out to these industries, particularly the manufacturing industries that are not yet aware of how high-performance computing can help them. If they're not looking for it, how do you find them? So that's a big challenge, and we do a significant amount of industry outreach. The other thing we were looking at doing is expanding this program and bringing in more national laboratories and broader industries. I'll end with talking about 3 different elements of this program that I think are really vital and make a big difference. The first was industry engagement. So I talked about reaching out before the solicitation happened, actually going out and visiting the sites of the manufacturing companies, bringing our technical experts and sitting down for half days talking about what their challenges are and how high-performance computing could have an impact, where it would work, where it wouldn't work. We've done this repeatedly, and it's been very successful, and we've gotten great proposals from there. But probably the most unique thing is what we do in the middle of our solicitation. So we have a down select, or we have concept papers come in, and when we down select the concept papers and ask for full proposals, we actually assign a PI from one of the national laboratories to work with the company in the development of that proposal. Because if you're not an expert in high-performance computing, it's very difficult to develop an effective high-performance computing proposal. That has worked out extremely well. Also, after the solicitations, we give significant feedback to everybody that submitted, those that we chose to award, but more importantly, perhaps those that we chose not to award, to make them understand, help them understand what high-performance computing can do. How could your solicitation have been better? Or I'm sorry, how could your proposal have been better? And we did that very effectively after the first solicitation, and we're seeing some return solicitations of much higher, return proposals of much higher quality. One of the interesting feedbacks we got from industry that I that I was surprised by was how grateful they were about having them bring us their problem, and then we look through our national lab system and find the PI that's going to work with them. They didn't have to keep up understanding of what all the different national labs do and who the experts are and where do I go and how do I do it. They just bring the problem to us and we do that matchmaking. That was extremely valuable to them. So the last thing I'll talk about is off-ramping. So we demonstrate, again, these are demonstration projects to make sure that HPC can have an impact on their problem. And then the next phase would be actually the implementation phase. So how do you then implement that? So we're working to help companies actually ramp off of the program and looking at things like HPC in the cloud. And there's a whole different sector of companies that are growing up around HPC and cloud that help companies actually do that. So there's also a transition road out. So that's all I had, and we'll move on to Will.
I'd really like to emphasize that you don't need to know what problem you have that fits high-performance computing to enter into this program. One, you can go directly to Peg and talk to her people. Hey, I got 10 problems. Which of these could I actually use your machine to solve? And then secondly, as she mentioned, if you get through that first concept paper phase, you'll get assigned someone to work with. So I think it can be kind of daunting, but I think that this program is very user-friendly. And so even if you never thought about accessing high-performance computing for your problems before, I'd highly encourage you to do it now. So next up, I'd like to introduce Dr. Will Joost. He's a technology manager in our Vehicle Technologies office, one of our best and brightest, and has played a real leadership role in standing up the whole model around our energy materials network, and is personally leading on the DOE side our LightMat consortium focused on lightweight metals and lightweight composites within the energy materials network. Will?
All right, well, thank you, Dave, and hi, everyone. So our national labs are awesome, right? They're awesome. I'm sure my national lab colleagues here would wholly agree. They have tools, right? Microscopes, computers, neutrons, that sort of thing. They have techniques, right? Ways to apply those tools. And most importantly, they have experts, people who know how to combine tools and techniques to solve materials challenges. And that tool technique expert combination, those resources are world-class and unique. Absolutely. There are just numerous examples of resources within national labs that you simply cannot find anywhere else. Inside that collection is the capacity to support accelerated materials development. So we've heard many times today about the importance of advanced materials. There's been some implicit discussion maybe about the importance of accelerated advanced materials development. And so we have, again, this set of capabilities at the national labs. We have industries and industry users who could potentially leverage that to perform accelerated materials development or to accelerate their own materials development. But in general, there seem to be two major questions when you are trying to engage with what is a very large and in some cases very complex national lab system. So you're an industry user, you have a problem, you have a materials challenge you would like to accelerate to a solution. Question number one is usually, how do I find the right resource, right? There's, let's say, 17 national labs with umptillion microscopes and all these other things. How do I navigate that entire broad network and find the right resources to help solve my problem? And once I've found it, how do I engage with the national labs quickly and effectively? We've had the opportunity in EE over the past several years to roundtable and workshop and chat with industry in a lot of different forums, and very consistently we get feedback that it's important that engaging with the national labs, that forming agreements happens quickly and happens effectively. So in response to this, we have begun to stand up what we're calling the Energy Materials Network. So the Energy Materials Network is a broad umbrella under which we have established several different consortia. So there's an electrolysis consortia for platinum group-free catalysts. There is a durable solar materials consortium. There is a caloric cooling consortium. And then there's lightweight materials, or LightMat. And so instead of talking about the entire energy materials network, I'm going to talk specifically about LightMat so you can understand a little bit about how the model works and how you can get engaged, how you can use these national lab resources. So today, LightMat exists. We have an operating consortia that is comprised of 9 national labs, the 9 labs that I show here. And so what we did was to create an organization that could be very responsive and very effective. We asked each lab to provide first a technical capabilities expert. So we have 9 technical capabilities experts, and those are people who are both material science experts and also really understand with a great degree of depth what tools and resources are available within their lab. Second, we asked each lab to provide a tech transfer agreements and contracting expert. So again, this is someone who works in the contracting office, who works in the tech transfer office, and knows all the intricacies and challenging hurdles and whatnot that exist specific to their organization. And then finally, we asked the labs to nominate, let's say, a data and tools expert. In the big, broad, wide world of accelerated materials development, materials data comes through as being an absolutely essential and foundational resource. And we want to be able to respond to industry's needs to manage and use that data. And so providing an expert that specifically focuses on that is very, very important. So now we've sort of got two pieces put together so far. We've identified a few problems. We need to be able to search the national labs, and we need to be able to form agreements quickly. And we've got something that's starting to look like a structure. And so the way that LightMat and, by extension, all of the other EMN consortia work is first, we've established a storefront represented by this person-looking character here. This is a single point of contact that any individual in the US manufacturing industry can access. When you want to engage with LightMat, you don't need to find a specific individual at the particular labs of interest. You call one phone number, one email address. I'll show you here at the end. If your interest is in searching the national labs for tools and techniques, we take that 9-member technical capabilities expert team that's matrixed across all the national labs, and we put them together. You ask this storefront, you ask this concierge about a resource that you might need, a materials challenge that you're having, you're basically getting free consulting, or we're paying for it, to help you navigate that system. The concierge passes your request down to this matrix team. They go through the catalog of resources that we've established, and they provide back to you a very straightforward answer. Look, for the materials challenge that you've described, we would suggest that this tool at Oak Ridge, this tool at Los Alamos, and this tool at Sandia can be combined, and that will do the job. Okay, so now you've found your resource. The next piece, of course, is forming agreements. And in a very similar way, we have a matrixed team of tech transfer and agreements experts. You ask the concierge, okay, it's time to work out an NDA. At this point, we have a single NDA that covers all the labs. So you as a company sign an NDA with LightMat, and you're covered. You don't have to try and navigate 9 different NDAs. We are right on the cusp of having a single CRADA for the entire network. So again, you don't have to try and bother with signing 9 different CRADAs. This is potentially a nightmare. We can accelerate through that process. But then in the event, right, that the agreements just become complicated, there's a hang-up, there's a hiccup, we have a team that we can tap immediately. Whatever national lab we need to go to, we know exactly who to talk to move that process forward. And on top of that, this concierge, who is literally 2 people at Pacific Northwest National Lab, they have the ball. It is their responsibility to make sure that the agreements go through. And so our metric for LightMat is from the day that a company comes in and says they have found the resource and they would like to start the process for an agreement, our metric is a 6-week turnaround. So we would like to have the agreements finalized and work started in 6 weeks. And we're going to drive very, very hard for that and sort of go through the continuous improvement process to make sure that it happens. And so last, you can see there's a vacant spot on my slide, so there must be something else. And there's, of course, the data, tools, and expert team. So as we go through, as you as an industry user run, let's say, a calculation on Edison at Berkeley, you produce 14 terabytes of data, and now you need to send that to someone else, or you need to perform analysis on these very large data sets. How can you actually do that? That's a more challenging problem than some folks recognize. And so we have a specific expert team who is dedicated to helping you navigate that process and making sure that you can find solutions. So this is the structure that we've implemented. Like I said, LightMat is up and running. You can engage with the concierge today if you'd like via email. You can call. If it's business hours in Richland, Washington, someone will pick up. And I would absolutely encourage everyone to go check out lightmat.org. Each of the Energy Materials Network consortia will have a similar website, but you can, for example, browse the catalog of resources. If you want to see what are the characterization tools for light metals that we have documented, you can click through and really explore the national lab system and find the tool that's right for you. So I do hope that you will reach out, and thank you very much.
That's fantastic. Well, next up is Dr. Sebastien Lounis, who's a co-founder of Cyclotron Road and is also their head of communications and marketing.
Thanks, Dave, and thanks to the council for hosting this great event today, and thanks to all of you for listening. My name is Sebastien Lounis. I'm a co-founder of Cyclotron Road, which is a program supporting clean energy innovators at Lawrence Berkeley National Lab. And today I'll just give kind of a snapshot of what this program is about and why we think it's filling, or at least trying to fill, an important gap in terms of US manufacturing competitiveness. So our program is founded on the idea that a single innovator or a founding team of innovators can make change that can launch in whole industries. And we think this is particularly true for what we call hard technologies. So physical technologies rooted in hard sciences that can have sweeping impact on the infrastructure that sort of underpins our critical industries in this country. So anyone that's been to our website can probably tell that we're kind of history buffs at Cyclotron Road, and I'm glad there's been some historical anecdotes already today. Does anyone know who this is? Someone shout it out if anyone knows. No? So this is Bob Noyce, who's sometimes called the father of Silicon Valley. So I thought, sort of, for a little bit of narrative, I'd go through his resume. So age 22, he completed his BA from Grinnell College in Iowa. Didn't waste any time, went to MIT, finished his PhD, I believe in physics. Age 30, founded Fairchild Semiconductor. Age 32, he received the patent for the integrated circuit. And at age 41, he co-founded Intel. It's a pretty impressive story when we talk about innovation and sort of making change in building industries. The point I want to make here is that, when you think about this story, you think about Apple, Microsoft, Google, Facebook, the big stories we have today, none of that would have happened, or at least it was all based on Bob Noyce and his co-founders taking a risk and diving into pushing a risky technology project forward in an entrepreneurial way. The question I want to pose is, what would have happened if they hadn't had a chance to get started? Now, let's fast forward to 2016. We thought that, this is actually Raphael Reif, who's the president of MIT. He wrote an op-ed in the Washington Post last year about our innovation ecosystem today. And I'm just going to read this, at least first part here. So he says, today our highly optimized venture capital-driven innovation system is simply not structured to support complex, slower-growing concepts that could end up being hugely significant, the kind that might lead to disruptive solutions to existential challenges in sustainable energy, water and food security, and health. Now, as Dave mentioned earlier, this is especially true in energy. So this is early stage clean tech venture capital funding over the last 5 years into early stage energy technologies. And as you can see, it's dropped off precipitously for a number of reasons that I won't go into here. So against this backdrop, I want to share another anecdote. So this is Natasha Cave. See if her name comes up there. Yeah, she's co-founder of Opus 12 and one of the first members of our first cohort at Cyclotron Road. So let's do the same game we did with Bob Noyce. So Tasha finished her BA from Olin College in Massachusetts at age 22. Went on to Stanford after taking a couple of years off, completed a master's in mechanical engineering, and then completed her PhD by age 30. And during her PhD, she developed novel catalysts for doing CO2 conversion. So taking CO2, using electrochemistry, and converting it into valuable fuels and chemicals. This is a big deal technology if you can do it at cost and at scale. She sort of saw the potential there and decided to co-found a startup to get this to market. Then the problem came. The problem was getting started. And Natasha put this really well in a video that Erie made actually recently, where she said, went and talked to VCs. They said, we'll support you once you have a prototype. But we couldn't afford to build a prototype because we didn't have any money. So they were sort of in this chicken and egg situation where they had a big idea, huge potential to change the economy, change the energy system, but could not get started. Cyclotron Road was built to support innovators like Natasha. So here's how it works. We run a national competition looking for the best and brightest innovators from across the country. And we take those innovators and we embed them at the national lab, where they can leverage the tools and the expertise to do the early technology and business development around their idea. Now, importantly, while they're there, it gives them the time to also learn how to be an entrepreneur. And a lot of what we do at the program level is supporting these innovators through mentorship, through coaching, through access to networks of folks in industry, former entrepreneurs, people with the experience of taking technologies to market. And we try to position them to actually take their idea to market with the right set of partners, the right type of capital, et cetera. So what has this meant for Atasha and her team? In just over a year being in the program, this is actually the team in the lab right here. They've set up a lab, they've grown their team, they've demonstrated record performance in CO2 conversion, and they had a chance to build that first prototype, which is shown here. Now, importantly, in addition to doing this, they're also, through connections through the program's network, were able to identify a commercial partner, Proton Onsite, that is going to allow them to basically integrate their catalyst and membrane designs into an existing electrolyzer, so they can demonstrate this technology at a scale that's relevant to industry. And just since it happened last week, they're recently featured in the New York Times. So, for these innovators, for Atasha, this program was the difference between, maybe pursuing this idea as an academic project at a university or at a national lab, maybe leaving the field, and actually getting a chance to chase that idea and try to drive it to market and try to show that it had the potential for commercial impact. So I'll leave you with this slide here. Dave mentioned earlier that there's some interest in expanding this program to other national labs and other institutions. This is our website analytics during our application window last year. In just over a month, we had about 25,000 visitors to our website while the application was open. And this is sort of the distribution of where those pings were coming from. So, I'll just leave you with a thought that, every one of those dots could be the next Bob Noyce, or could be an Atasha Cave waiting to take their technology to market. Thank you. And I wanted to acknowledge the Erie Advanced Manufacturing Office for being a founding partner. I clicked through too quickly there.
Well, I think this program is incredibly exciting. You may have seen that big bubble on Washington, D.C. That was me clicking. Yeah. I think this is a total game changer. And I think that, one, we are committed to spread this to other laboratories. I want to thank Sebastien, Ilan Gur, Mark Johnson, our AMO office director, for having the vision to try this. We're trying new things. This might not have worked, but it seems to be a really exciting new model, and we'll be expanding it to a total of 4 labs, hopefully by the end of the year. And I see this as a very highly leveraged, extensible model. I think Mark, it's about $3 million a year kind of per lab. And so I actually think we could expand this to other universities, other national laboratories, and I think there's also an opportunity to get corporates involved more, and I'm also hearing more and more from the philanthropy and the foundation community that this might be something they'd be willing to support as well. Again, as I said this morning, imagine more than 100 Atasha caves around the country in our national labs, in our universities, going through a program like this. I think it's a game changer. So very excited about that. We're going to close strong here with Bill Peter, who's the director of the Manufacturing Demonstration Facility for Additive Manufacturing at Oak Ridge National Laboratory.
Great. Thank you, Dave. Really appreciate the invite to come talk about something I love to talk about. Thank you, Deborah and Chad, as well, for inviting me to speak. Before I get started, I want to thank Dave, Mark Johnson, and the Advanced Manufacturing Office for really enabling this vision and supporting the idea of the MDF. We talk about the importance of the partnership with industry. Also, a very important partnership is the national laboratories with Department of Energy, and really being able to work to pull these visions together and make them useful for industry. So I'm going to go through and take a quick look of the MDF and give some ideas to the various different things that we are doing through this. First, I'm going to talk just about the structure of the MDF. The Manufacturing Demonstration Facility was set up about 5 years ago, and the whole idea was to try to create a place where, while the national laboratories were working on advanced manufacturing companies could come in and take a look at what we're doing and work side by side with us. Quite often it is very difficult for a company to go through and invest in a lot of capital equipment. Also difficult to get a white hat type organization where you're getting ideas and a feel on what is meaningful within these various different technologies. Where should you be going? And so that's how this started off, and it's worked out very, very well as far as how we can go through, bring in companies and talk to them. It's that same public-private partnership. When we say that, similar to what Peg was talking about, when I say public-private partnership, that's because DOE is funding us to work with industry. Industry is also bringing their own research dollars to look at the problems that we're looking at to solve. There are three different, when we opened this up, we had about 6 pillars, but we really focused on 2 areas, additive manufacturing and carbon fiber composites. And to us, these are 2 areas that we think we have huge potential, especially in the additive manufacturing areas. We talk about this. There's high potential, but it's very embryonic as to where it is right now. And so we have a lot of tools at the laboratory that really help in this space. So there's 3 different activities or areas that we work with industry. The first one being industry collaborations. This is where companies come over and bring us their problems. Typically, we start off at a 40K type activity, 40K sponsored by DOE, 40K sponsored by the company. It can go to a phase 2 where we go to 200K and 200K activity afterwards. But once again, this is focusing on the company's challenges or concerns in additive manufacturing. Another area is our core research and development. And this is a space where the National Laboratory has really started to put a strategic plan on where those critical areas, whether it's materials, equipment, or the computational applications to solve additive manufacturing. And so these are really these strategic goals. I heard earlier talk about qualification and looking at additive manufacturing. That's one of our goals, is how can we qualify parts where at any given point I can change the microstructure that you see in these parts. These are big problems, and so we're looking at data analytics and using new characterization tools to really focus on that. The third area is education and training. And as I get into education and training, there's a whole range of different activities that occur at the MDF. The first one that I'll talk about is FIRST Robotics. We have quite a few employees and staff members that really enjoy getting high school age kids into the facility. We support between 50 and 200 students per night during the build season for FIRST Robotics. If any of you aren't familiar with FIRST, I strongly recommend looking it up. It's a fantastic program to introduce kids to how to go through assemble robots, how to write code, and do a lot of the different activities that are very important for youth today. For us, where we're able to do is basically show them how additive manufacturing composites can actually change the way they build their robot. These are basically lessons they're learning that they can take with them afterwards, and it's amazing how we've seen that expand in their frontiers for manufacturing, where they'd like to go as they go off to college. We have about 70 internships usually during the summer. So we have a lot of everything from high school to graduate students that are coming in during that time to work with us. We just initiated a new program called Ramp Up, Research of Advanced Manufacturing Program University Partnerships, where we selected 9 universities to actually work on those core problem sets I was telling you about, work hand in hand with us on some of those issues. So we're very excited about that program starting as well. The last area is actually in professionals, and some of the things that have happened when it comes to training with professionals is Boeing, for example, initiated a training program that they house at Oak Ridge. They've gone through, and basically they have a lot of trouble in going through and figuring out how to relearn or teach designers on what would I do differently in additive than what I've done with conventional machining practices and other manufacturing. And so this has been a great scenario for them to be able to come in and essentially learn. There's a week-long curriculum that we worked with Boeing and the University of Tennessee to put this together. And so they're able to use that. That's a week-long program that Boeing pays for. The last thing is also with the University of Tennessee being there right next door to us is we have 2 different governor's chairs that are at the University of Tennessee, and that's brought a lot of students from the local colleges also in to start learning and seeing what we're doing. One of the things that I'll stress, and you've heard a lot about neutrons, computation, materials, as well as other advanced manufacturing, one of the things that we've really found is that the MDF has been the portal to the laboratory. Companies come in and they may say, hey, I came in to look at laser deposition, what you were doing in laser deposition, and in the end, we're getting them integrated with what we're doing in the computation space, or it may be what we're doing in spallation neutron source. Talking about companies coming in, we've had a lot of different companies that have come in. Actually, to date, it's reaching about 13,000, just over 12,000 visitors that have been at the facility. Last year alone, we had over 4,600 visitors. This year, we will hit over 5,000 visits by the time we're finished. That's people that are coming to the facility. When I talk about actual companies, last year we had over 600 companies come to the facility. We've had over 2,000 companies that we've worked with and spent a day talking about what we're doing and how it may change their business strategies. So that's been really exciting. By having that amount of companies, we get to spend a lot of time in understanding their problems and really helping to work with them solve those issues. I don't know if you could tell in the video, at the end of the session as we were putting that together, they asked me, what do I enjoy most about my job? That's one of the things I really like to do, is really see how do these advanced manufacturing capabilities really help industry's problems, and does it make sense to go that way? We've ended up initiating over 90 active or completed CRADAs with companies' cooperative research and development agreements. About half of those are active right now. The other half, about 50, are completed, and that is across over 24 industry sectors. As we go through and look at publications, this is something we've really started to engage and look at. I think with around about 25 staff, we will have about 100 publications this year alone. And this is something that beyond that visitation, we're really trying to see how do we get what we learn out to the companies that we're working with. So this is something we're very proud of and want to continue to increase the number of publications that are coming out. The other thing that I'll mention on this slide is industry fellows. One of the things in this in the MDF is we actually have had companies that have contracts with us that actually are housed and have an office inside the facility and are there full time. I'll give you an example. Dave Dietrich, who is over Boeing's metal additive manufacturing, he sits inside of our facility. RCAM, one of the equipment manufacturers, they have an individual that's at our facility. Local Motors, Cincinnati Incorporated, a lot of these have had individuals that actually sit with us, work with us day to day as we go through and work on these big challenges in additive. So one of the major elements, and we were talking about time, contracts and getting those in place are really important, but also giving ourselves set goals that really push us to go through and fulfill and advance the technology. And so one of the things you heard a little bit from Dave earlier talking about these timelines. Yes, indeed, it was about 6 months from after signing the CRADA with Cincinnati Incorporated to having the first working large-scale printer, the BAM system, that was on the order of about 6 feet by 15 feet by 3.5, 4 feet tall. And the interesting part by the IMTS was not just developing the printer, but the fact we had to print out a vehicle right upon completing this. And a lot of details in this, the slicing software, the extruder, how you put this whole machine together. But it was a forcing function. It made us come up with a plan very, very quickly. What that's led into is the fact of local motors opening up micro factories. We have one that opened up in Knoxville, Tennessee. There's another one that opened up in Washington, D.C. And these are thought of, you could imagine, like your auto dealer where at about that rate, they're producing vehicles locally at that place with a much lower cost infrastructure. At the same time, you've had Cincinnati Incorporated who've been selling these machines. When we went through and had this at IMTS, they sold their first 2 machines, and they've continued now to go through and sell more machines as we're looking at new applications for them. The last thing that I'll talk about is where are we at now? And really, I've talked about how the BAM went through and helped these 2 companies. We're now seeing a huge area when it comes to the die and tool industry. Over and over again, as companies come and talk to us, this is one big issue. The idea of waiting 6 weeks to 6 months and paying anything from $1/8 to $250,000 for a moderate-sized tool is something they're trying to see, how do we change this? Any place you have manufacturing, you've got to have tools, molds, dies. And so as we start to go through and look at these type of areas, one of the areas is looking at in autoclave composite tooling where I can do layup work on top of this. This is an example that we just demonstrated recently where we basically were taking this tool that we printed out with the BAM. It's a PPS with about 50% carbon fiber loading, where we went through and actually tested it at Boeing inside their autoclave. It went up to 350 degrees Fahrenheit and kept its tolerances. This is a huge area that can really change a lot when it comes to the overall cost structure for looking at some of the composite layups. There's other areas we're looking at, sheet forming, as well as other space that we think this could have a huge impact. And with that, I'll stop and let questions.
Great, thanks. We've got a few minutes. I wanted to open it up to the floor for any questions for the panel here. See someone in the back here? Great.
You go.
Jim.
Okay. Jim Phillips, Chairman and CEO of Natamac. So we've worked with Oak Ridge for years and done sponsor research, transferred technology out of there, turned it into some pretty neat stuff, and we love Oak Ridge. Okay. Having said that, so let's say you're a smaller company and you come up with some incredible invention and you want to get use of the labs, work with the labs, and let's say, just for the heck of it, it's gravity-resistant materials. And how do you protect a smaller company? You know, I noticed all your sponsors, BASF, I mean, these huge, gigantic Lockheed Martins, and you walk in and you show this stuff, and you know you've signed an NDA for whatever that's worth, which is usually nothing. I mean, seriously, I mean, and it's so earth-shattering that, you know, several people are going to look at it, see it, and it's going to make a world global difference over a period of a year. How do you go about really protecting that kind of stuff?
So great question. One of the things I failed to talk about on the slide, actually 2/3 of those industry collaborations I was talking about are small to medium enterprises. And it is very important, especially as you have different people inside that facility. There are certain areas that we're going through and that we're doing at our core research. There's others that have to do with the proprietary information that has to do with design and some of the activities that are with those companies. And that's an area that we have to be very careful with, and we spend a lot of time in making sure how we isolate it and go about making sure we protect it. Of course, the overall language of the contract, as it was mentioned earlier, the short form CRADA, when we put it together, one of the things we pushed really hard for was making sure we had the best terms we could with DOE on how we have that contract with the company. And that's paid off, I think, in making sure companies are comfortable with what we're doing with them on the front end. But it is something that we think about and work on very heavily as we go day to day.
And Jim, I might add that I think in the end it comes down to forming long-term trusting relationships, right? So that I think it's good for anyone to start, you know, especially if you're nervous about something like this, start smaller. You know, you maybe don't hand over the keys to the kingdom in your first, you know, conversation with lab folks, but start on another problem that maybe is important to you but isn't the keys to the kingdom. And then I think as you work with someone, you know them, you trust them, you know they're not going to say anything to anyone, and I think that's another good way to go as well.
Hi, Diane Pullman, Terra Innovation Associates. The question is for Sebastien. On Cyclotron Road, it has been evolving over the last year. Could you take just a minute and address how it has evolved and why, and secondarily, some of the IP issues with the entrepreneurs?
Sure. Yeah. So that's a great question and an important one for people to know about how it's evolved. So when we launched the program as a pilot about almost 2 years ago in July 2014. At that point, it was funded internally by Lawrence Berkeley Lab, and basically to get the program going and start to prove out that there's actually some value in providing this connection between these innovators and the lab. We wanted to get started quickly, and the quickest way to do that was actually to set it up so that we hired the innovators actually into the lab as employees, making them employees with all the same IP restrictions that a normal employee of the lab would if they're developing something there. We knew from the beginning that that was not an ideal structure, particularly around IP and other things, and we've now moved actually pretty recently. So we just brought on our second cohort of projects, and also most of the first cohort has transitioned, where going forward, the projects are supported as small businesses. So before they join the program, if they haven't incorporated already, they do incorporate, and they are supported through a CRADA with the lab. So in the same way that any other business working with the lab would have a CRADA, the IP terms are the same. So it's actually much more favorable for the innovators, much more protective of their IP, and I think it actually makes a lot of sense, and it's really the appropriate agreement structure for these types of projects to work with the lab. So that's going to be the structure moving forward for this program, and I imagine for the other programs that will be starting up.
I think that brings up an important point culturally for the department, that we need to continue to be willing to try new things and take some risks. And if things don't go exactly as we hoped, we pivot and fix it. And so we've had that experience with a number of these programs where you start out in one direction and it ends up not being doable or crosses over a fuzzy line somewhere in DOE regulationville, and then we figure it out and we move it forward. But you can't let the possibility that something could go wrong keep you from trying something new. And I hope that we keep pushing in that direction as an organization going forward. We have time for one or two more questions. Bill.
Thanks. William Dahl with Sinaitis Group. So Dave, as you know, I work with private investors. I just want to say this is a great idea. Like the innovation you're doing, there's a huge gap between private capital and the infrastructure of the national labs, and you're starting to bridge that. So kudos, great idea.
Thank you, William. Any final question for the good of the order? It has to be an optimistic, forward-leaning, positive question.
To end them. Otherwise, we need another one.
We talk about NMI will solve all research needs of small businesses. The research needs are extensive. NMI are narrow efforts. How will we do that in the long range? The short range, I agree. NMI in North Carolina will address the issues, Cree's issues, some other people's issues, and all that. But long range, how will we do that? Will we create 100 of NMIs, or may I have, whosoever wants to answer that question or thought about it, I would like to hear.
Well, I think you're just hearing about a few innovative new R&D and partnership modalities that the Department of Energy has put in place over the last few years. But my office, the Office of Energy Efficiency and Renewable Energy, invests about $2 billion into research, development, demonstration across the board in sustainable transportation, renewable power of the grid, built environment efficiency, advanced manufacturing. And what you've seen is a very small fraction of all the work we do. We do open competitive funding opportunities based on roadmaps we develop with our stakeholders. We do direct lab funded partnerships that are different from any of the models we've talked about today. But I think what I love about some of these models is they're really clear front ends to engage with the laboratories or to engage with the department. And then I think then what people find is once you get in the door, then you start to learn about all the other ways that we can work together. I think in particular, it should be noted about half of our, the $2 billion, interestingly, is about 20% of all federally funded innovation in the whole world. So it's significant. But I think it's important for people to recognize that this relationship, you hear a lot about our national labs. About $800 million of that $2 billion this year will go into national lab partnerships. And those are very flexible. People should understand that, you can go to a national lab, identify a big opportunity for a partnership, and as long as it's squarely in the mission space of the Department of Energy, we can go direct fund the other side of that partnership with you. So there's a lot of flexibility, and I've really encouraged people to hug a lab, as I say, today and going forward, because there's a lot of flexibility in that relationship. The capabilities are phenomenal. And so I guarantee you that any problem that you have, we've got the tool in the tool belt to solve it. Mark Johnson.
One last sort of hopefully upbeat question. I'm going to ask Bill to comment on this. He touched on the FIRST Robotics effort real quick. And one effort we've actually worked on over the last year is saying there's something like tens of thousands of high school students per year that are graduating having been through FIRST Robotics. And I know you guys are working on how you can wind up helping them bridge from going from high school into college and then working with companies in an internship in their sort of first couple of years after they're in college and using that cohort. I wonder if you could comment, first of all, update my numbers. How many students a year are there in FIRST Robotics that nationwide? These are the people that are going to be the manufacturing leaders of the next generation. Yeah. And then, if you could give a quick update on that sort of partnership program, what's going on with that?
Yeah, I'd have to, Craig, how many are total? Do you know nationally how many? 10,000.
10,000 a year.
And you're aware some of the neat things that have recently occurred in fact, DOE put together a internship program with FIRST recently that was looking at the idea of sponsoring alumni from FIRST to come and do an internship at companies for the year one with the expectation that in year two the companies would then pick it up. And that's something I think that's really exciting that starts to give opportunities for these kids. One of the really interesting things with FIRST is you're pulling kids that really enjoy working inside of STEM, or I'll even say STEAM activities that you really want to pull into this. I mean, and so I think that's been really important. I think creating these internship activities beyond that is something that's really important. One of the big things is just having the mentors get engaged, and that's why I bring it up with many of you. If you're in manufacturing, it is infectious. A lot of the people at Oak Ridge have gotten started that are at the MDF, and once you get started, you get hooked. Last year was my first year, and I'll be continuing to do it year after year. It's a lot of fun, and the kids, it's grown. When we started, there were only a handful of mentors. There's now 30 mentors for one of the local schools, and now you're starting to see that same trend with the other high schools that are also in the area.
Well, that's great. One thing I wanted to note is that I hope that those of you who could be private sector partners, have noted how much of an emphasis there is on being user-friendly in these new models. And that's a real important emphasis that I'm seeing across all of these models. That's very important. In addition to the exciting innovation models, they're actually really focused on being user-friendly for the industry. So with that, been a great panel. Thank you for the innovative work that you're doing. Great questions from the audience, and let's give them a big round of applause.